So linear combinations is a way to combine, and we're going to do it mostly right now with equations that are two variables. But you can do it with three variable equations and even more variable equations than that when we get more complicated. But what you have to do when we're doing linear combinations is both of my equations have to be written in the same format. So right now, both of these equations are written in slope-intercept form. And amazingly enough, they look identical to the ones that we just did on the board. But if they're written in exactly the same order, I'm going to rewrite them one over the top of the other one. So y equals 3x minus 4. And then y equals x plus 4. So some people call linear combinations, they call it the elimination method. All right, that's not really the mathematical term, but you can think about it in terms of like it's called elimination because I'm trying to eliminate one of the variables. So if I have them one over the top of the other, is there something I could do between those two equations that would eliminate one of the variables? And the answer is yes. If I subtracted those equations from each other, I would look at that and say, okay, y minus y is 0. The y's have now been eliminated. Equals, and then I have 3x minus x. 3x minus x is 2x. And then negative 4 minus 4 is negative 8. Got to keep track of your negatives if you choose to do subtraction. Now we're going to do a couple others later, and we'll find that if I can set it up as addition, that actually ends up being a lot easier. But now I'm down to a single variable, single equation. Need to move all my numbers to one side, all my variables to the other side. Lucky for me, my variables are already on the right side. So I'm going to move this 8 to the other side. Inverse properties, right? So I'm adding 8 to here, adding 8 to here, because 8 equals 8. I'll have 8 equals 2x, and then I will divide by 2 to both sides. X equals 4. Pick either of my equations, it shouldn't matter. Substitute that back in. Y equals 4 plus 4, and that's 8. If I do it here, I better get the same answer. Y equals 3 times 4 minus 4, so y equals 12 minus 4, or y equals 8. Yay, it's the same number. That means I probably did it right. My final answer would be 4, 8. Don't forget to write it in XY format there as a coordinate pair, because what I'm really looking at, and what we talked about when we first did this, we solved by graphing first, then we did linear substitutions, then we're doing linear combinations. But if I were to graph this equation and graph this equation, they would intersect at that point. And just while we're at it, quick little review. The slope of this line is 3. The y-intercept is negative 4. If I wanted to be parallel to this line, my new line would also have a slope of 3. If I wanted to be perpendicular to this line, the slope would be negative 1/3 because we take the negative reciprocal. So there's your quick little review of the day. Again, because we'll have an exam coming up in the first full week of November. So be ready for that. Here you go. So here's my next two equations. The first thing I look at is, are they in the same format? And the answer is yes, they both are. When we did the last one, they were both in slope-intercept form. These are both in what's called standard form. Standard form is ax plus by equals c. Just in case you don't remember that. Again, throwing that out there as review. If you're ever asked to create the equation, then put it in standard form, this would be standard form. They're both in standard form. They have the x, then they have the y, and then they have the equal sign, and then they have the number. So what I can do is I'm going to line them up one over the top of the other. 2x minus 3y equals negative 13. That's my first equation. My second equation I bring down is negative 2x plus y equals 7. And then I look at those two equations and I say, is there anything I can do directly from one equation to the next that will eliminate one of those variables? And the answer, much like on the last one, also is yes, there is. I have a 2x and I have a negative 2x. If I add those together, right, the one we did on the previous slide, we subtracted. Adding, I think we would all agree, is typically an easier process and method. So if I can add, I'm going to do that. So in order to add them, I would be looking to see, are either of them the identical number, just one's positive, one's negative. So this one's positive 2x, this one's negative 2x. That's awesome, they are. If I wanted to eliminate the y, which we're not going to do on this one's negative 3y. This one's a positive 1y. What we're going to do on the next slide is say, well, I could take this whole equation here and multiply it by 3. So I'd have 3y and negative 3y. But we'll get to that. Let's just finish this one the way we have it for now. I'm going to add these up. Those two, 2x and negative 2x, add to 0x. I'll write 0x, even though we typically don't. All right, then I have negative 3y, pay attention to the y's, negative 3y plus a positive 1y, so negative 3 plus 1, I'm at negative 2y equals, and then I have negative 13 plus 7, that's a negative 6, and only because I just don't like that 0x, I'm just going to rewrite it as negative 2y equals negative 6. Solving for y? Divide by negative 2. Y equals, and then again, always keeping track of those negatives. Negative divided by a negative, I know my solution will be a positive. 2 goes into 6 3 times, my y is 3. And then I'm going to pick one of these equations, or both of them, doesn't really matter, to finish this out. So I'm going to take this, I'm going to plug it up there into that spot, and I'll have negative 2x plus 3 equals 7. Again, all I did was substituted in the y into this y. And then I go through my process. All right, I need to subtract 3 from both sides because negative 3 equals negative 3. Whatever I do to one side, I do to the other. Negative 2x equals 4. I'm going to divide by negative 2. Because negative 2 divided by negative 2 is 1. I'll be left with 1x equals 4 divided by 2 is 2, but a positive divided by negative, it's a negative 2. So my solution should be negative 2, comma 3. I'm going to do it up here as well to see if I get the same answer. And I'll have 2x minus 3 times 3 equals negative 13. So again, took the 3 for the y, plugged it into that y for 3. I will have then 2x minus 9 equals negative 13. I am going to add 9 to both sides because 9 equals 9. And I'm left with 2x equals negative 4. Negative 13 plus 9 is negative 4. Divide by 2. X equals negative 2. Yay. It works for both. So now, slightly more complicated. I look at these two, and I notice right away that I do not have okay, first, they are in the same format. AX plus BY equals C. This one is AX, a number X plus a number Y equals C. But if I wrote them one right over the top of the other one, the X's and the Y's, they don't just add away to 0. And I want them to add to 0. So what I try to look for is there something convenient I can either do to this equation or something I can do to this equation that will make either the X's or the Y's identical to the other problem. And what I notice right away is this is a positive 2x, this is a negative 1x. So how can I make this a negative 2? I would do that by multiplying this whole equation by 2. And I can do that because whatever I do to one side of an equation, I do the other side of the equation, that kind of thing. So I'm going to bring that down. I'm going to bring this one down first. And that would be then negative 2x plus 6y, right, distributive property, there, and then equals 20, because that 2 has to multiply all the way to the last thing as well. I'm going to bring the second equation down directly underneath it, 2x plus 8y equals negative 6. Now, if I add, I am going to be able to get rid of those x's right away. That's why some people call this the elimination method. I'm eliminating the x's. Negative 2x plus 2x, 0. Yay. 6y plus 8y, 14y. 20 minus 6, or plus a negative 6, 14. Divide both sides by 14, y equals 1. Let's bring this up into this equation. 2x plus 8 times 1 equals negative 6. 2x, which is then just plus 8, equals negative 6. Subtract 8 from both sides because negative 8 equals negative 8. 2x equals negative 14. Negative 6 plus negative 8, or negative 6 minus 8, either way you think about it. Divide by 2, x equals negative 7. Let's hope I get the same thing over here. And I'm going to do the original equation, not the multiplied one. Negative x, excuse me, plus 3 times 1 equals 10. Negative x plus 3 equals 10. I am going to subtract 3 from both sides because negative 3 equals negative 3. And I have negative x equals 7. And then to get rid of that negative, some people, you can divide both sides by negative 1. You can multiply both sides by negative 1. Or you can just say, I'm just going to switch the signs. Make this positive, make the other one negative. But yay, again, same number, my final answer, negative 7, 1. If I graphed those two equations, that is where they intersect. And if I do it this way, where after I find the x and I plug it into both equations, if I get the same y, I do not have to go back and check my answer later. And then, again, each problem here, I'm kind of stepping it up one more level. They're both in the same form, which is nice. I don't have to move anything around. But if I look at this, I've got a negative 4x and a positive 3x. I can't do one thing that's going to make this into a 4 or this into a 3. So I look at the y's. 2 and 3. Well, is there one thing I can do that makes this 2 into a 3 or this 3 into a 2? Not easily. So then what I'm thinking is I'm thinking like fractions, but I'm not doing fractions. I'm thinking about common denominators, kind of the idea in my head. Is there a number that I could make this 4 into by multiplying this whole equation by something, and this 3, and multiply this whole equation by something, that ends up being the same number? And the target would be the number 12. So I'm going to take, and since one is positive and the other one's negative, I'm going to love the fact that that's true. So I'm just going to multiply this first equation by 3. I'm going to multiply my second equation by 4. And when I do that, I'll bring this first equation down. It will be 3 times negative 4x, which is negative 12x. 3 times 2y, which is plus 6y, equals 3 times negative 11, which is negative 33. And then my second equation I'm going to bring down, 4 times 3x, positive 12x, 4 times negative 3y is negative 12y. There's my equal sign. The equal sign's in the same spot. 4 times 5, positive 20. I didn't have to write the positive there. I tend to do it because for me, my biggest mistake I make is I lose track of positives and negatives all the time. So I overemphasize a lot of times which ones are positives and which ones are negatives. And you've seen me do it when I write a giant subtraction sign, so I keep track. All right, but I'm going to add these two equations because if I do, my first terms, negative 12x, positive 12x, they add to 0. I've eliminated the x's. I will then have 6y minus 12y, or 6y plus a negative, is negative 6y. Negative 33 plus 20 is negative 13. Well, that's not a very fun number, but that's okay. Divide by negative 6. Y equals 13 over 6. I'm going to take that, like we've been doing, and I'm going to bring it up into one of these other equations. So I'm going to move this over just so I have space. I'm going to move it up there. 3x minus 3 times 13 over 6 equals 5. 3x equals, now you can do it a couple ways here. A lot of times I'll just go times 1 and make it 30. Ooh, that's not an equals. Why do I have an equal sign there? That's a minus sign. And I'll have 3 times 13, which is 39 over 6, equals 5. I don't like to work with fractions. I'm going to get rid of fractions. I'm going to get rid of fractions by multiplying everything by the denominator, 6. I'll have 18x minus 39 equals 30. Now it looks a little bit more enjoyable. And maybe enjoyable is a little bit too much for you right now. It's less painful. How about that? Add 39. 18x equals 69. Divide by 18. X equals, let's see, 3 goes into both of them. So the denominator can be 6, because 6 times 3 is 18. 3 goes into the top 23 times. And that would be reduced. So 23 sixths, comma 13 sixths would be the possible numbers. What I'm going to have you do is see if I made any mistakes. I want you to take that, put it back up into this equation, and see if you can get the same number as an answer. So I went through it as you were working through it, and get to the end, and I got this weird number of 92 over 24. And then if you do, if you're wondering, like, how do I get that to here to find out if it's the same as 23 sixths? I just said, well, how do I get from 24 to 6? Well, I divide by 4. So I checked, is 92, what's 92 divided by 4? It's 23, so 4 divided into both of them, so it gives me 23 over 6. Yay, same numbers. I can then confirm that this indeed is my final answer. And of course, we have to work our way into a nice, big, nasty looking word problem. You purchase a rectangular waterfront lot along a river's edge. Here's my river's edge. We're going to pretend it's a straight line. And the perimeter of the lot is 1,000 feet. So here's my rectangular lot. The perimeter is 1,000 feet. That means if I add up all the lengths, this length, plus this length, plus this length, plus this length, it should equal 2x plus 2y equals 1,000 feet. To create privacy, you decide to build a fence on 3 sides, obviously not along the river because you have riverfront property. You don't want to have a fence in front of your river. So you're going to do on 3 sides, not along the river. The lot's front length costs $25 per foot. So the front, for me, that's a Y. The Y costs $25 a foot. So in terms of equation, for every foot Y, I'm going to multiply it by 25, because that'll tell me how much I pay for that front side. And then the other 2 side lengths are $5 per foot. So that will be plus 5 times the 2 sides, 2x. Because there's 2 sides that are x length. And I want it says the total cost of the fencing for all 3 sides will be $9,500. At this point, I have 2 equations. Well, let me just rewrite this one. 25y plus 10x equals 9,500. Are they in the same format? X plus y equals a number? Yes. I can use the elimination method. Can I immediately just add them one to the other and get rid of a variable? No, I can't. So then I go through the process of what I did before and say, well, what can I do to one equation to make it the same for the other one? And I'm looking at this y, this x here, 10x, 2y. I'm going to take this equation and multiply it by, our instinct is 5, but I'm going to do -5 because I like to add equations, not subtract equations. So when I do that, I'm going to bring this down. -5 times 2x is -10x. Oh, I have them backwards around, don't I? Let me do this. Let me rewrite this as 10x plus 25y equals 9,500. So again, all I did is I just wrote these in the other direction. A little curve in that one. So now it's -10x. And it will be -10y equals -5,000. When I do that, right, multiplying all 3 of them to make negatives, now I can add the 2 equations. 10x plus -10x is 0. 25 minus 10 is 15y. 9,500 minus 5,000 is 4,500. My y value equals let's see, 300. 15 goes into 45 3 times. Right, 15, 30, 45, there we go. And then 2 zeros at the end. So the front of that lot is 300 feet. Which means this side over here is 300 feet. The total perimeter we said was 1,000 feet. The other 2 sides that we just did were 300 feet each. So that's 600 feet total, 400 feet left. There's 2 sides. Both are the same length x. So I'm going to divide that by 2 and get 200. Or the other thing is I take this, put it into that equation for y, and then solve for x. It's the same idea. Typically, the biggest challenge with a lot of these types of problems is looking at the information they give us and seeing if I can create an equation about it. I will almost always say, when in doubt, draw a picture of what they're trying to represent. Then start putting variables down for things that we don't know. If I have a rectangle, because my knowledge of geometry is pretty good, we remember that opposite sides of a rectangle are the same length. So instead of having x, y, and z, I'll have an x and an x, and then a y and a y, and perimeter, remembering what perimeter is, adding up all the sides to go around. Coming up with an equation like this is probably the newest thing that we don't do a lot of practice with. But there will be a few of those to work on and to check your understanding as well. But you'll build from the easy ones like we started today until the more complicated ones where we ended.